Hello friends, today we are going to solve another question in cubic polynomials. I will strongly urge you to refer to the previous videos in this playlist so that your concepts are really strong. The question says that verify that these are the roots of a cubic polynomial p of x, which is given here, and also verify the relation between the zeros and the coefficients. So you see p of x, this is the solution. It says p of x is equal to 3x cubed minus 5x squared minus 11x minus 3. Now let's see whether p of 3 satisfies this equation. It becomes 3 into 3 cubed minus 5 into 3 squared minus 11 into 3 and minus of 3, which is equal to 3 cubed is 27, 3 is 81, minus 9 5s is 45, minus 33 minus 36, which is which is minus of 3 and this is equal to 81 minus 45 minus 33 minus 3 is actually equal to 0. So this is certainly a root of p of x. Let's put p of minus 1 by 3 here. This becomes 3 into minus 1 by 3 the whole cube minus 5 into minus 1 by 3 the whole square minus of 11 into minus 1 by 3 and minus of 3. This will be equal to minus of 1 by 9 plus of 5 by 9 plus of 11 by 3 and minus of 3. On solving this one further, you get, let me take the LCM as 9. I get minus of 1 plus of 5 plus of 33 minus of 27. And what do I have? Am I getting a 0 or have I made a mistake here? Minus of 1 by 9 plus of 5 by 9 plus of 11 by 3 and minus of 3. 3 3s are 9 3s are 27, 28. Sorry, this will be a minus here, and that was the mistake, and I get a 0 here. So p of minus 1 by 3 also satisfies the equation. Now let us put down p equal to minus 1, and we put down p equal to minus 1. I get 3 into minus 1 whole cube minus of 5 into minus 1 square minus of 11 into minus 1 minus 3, and this will be equal to minus of 3 minus of 5 minus plus of 11 and minus of 3, and this is again equal to 0. So we have very well verified that all three of them are actually the roots of the cubic equation p of x. Now it wants us to verify the relation between the zeros and the coefficients. Let me see if I can fit everything in the screen. I can't. So it says the zeros and the relation between the zeros and the coefficients. So the sum of the roots will be equal to alpha plus beta plus gamma, and this is equal to minus of b by a. Now you see alpha, beta and gamma are 3 minus 1 by 3 and minus 1. So I have alpha is equal to 3 plus beta is equal to minus 1 by 3 and gamma is equal to minus 1, and this is equal to, I am going the alpha plus beta plus gamma route, is equal to 3 minus 1 minus 1 by 3, that is equal to 2 minus 1 by 3, that is equal to 5 by 3. Now alpha plus beta plus gamma should ideally be equal to, from the equation minus of b by a, it should be equal to alpha beta plus gamma. This should be equal to minus of b by a, which is equal to, you see, b in this equation is equal to minus 5. You see, b is this term, this term is your b. So if I have to expand here, a is equal to 3, b is equal to minus of 5, c is equal to minus of 11, and d is equal to minus of 3. So b is equal to minus of 5, and I have a minus in front of the minus of 5 divided by a, which is equal to 3. So this becomes 5 by 3. So the first relation is verified. Now let's do the second one. That is, now let's do the second one. That is alpha beta plus beta gamma plus gamma alpha should be equal to c by a. Okay, now let's see, alpha beta plus beta gamma plus gamma alpha is equal to 3 into minus 1 by 3 plus minus 1 by 3 into minus 1 plus minus 1 into 3. And if you solve this, you get minus of 1 plus of 1 by 3 and minus of 3, and this is equal to 1 by 3 minus 4, that is equal to 1 minus 12 by 3, that is equal to minus 11 by 3. This is the second part, and here what I get is alpha plus beta plus gamma should be equal to c by a. C by a is equal to, you have to check c by a over here. C is minus 11 and a is 3, so c by a is minus of 11 by 3. So these two are also checked. Now look at the third part, which is the product of the roots. So we know that the product of the roots, is equal to alpha, beta and gamma, which is equal to alpha is equal to 3 into beta is minus 1 by 3 and gamma is minus of 1. Let me verify if I've written that right. Yes, 3 minus 1 by 3 and minus 1. So this is equal to 1. And from the coefficient perspective, product of roots should be equal to minus of d by a. And we have seen that d over here is equal to minus 3. You see, d is equal to minus 3 and a is equal to 3. So when I do minus of minus 3 by 3, that is equal to 1. So this also matches, and this is what we were aiming for, which is we wanted to practice matching the coefficients of the quadratic equation. We wanted to match the coefficients of the quadratic equations with their roots. So just to summarize, I'll put down all the formula here once again, which is alpha plus beta plus gamma is equal to minus of b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta and gamma is equal to minus of d by a. You should remember these formulae really well. I hope you found this video useful. Do like, share, comment and subscribe with your friends. I urge you to subscribe so that you receive proactive notifications of all my videos, which by the way I upload every evening at 8 p.m. In case you want me to solve anything from the syllabus of class 9 to 12 mathematics, do put down your queries in the description box or WhatsApp to me at the number given in the description. Till then, keep working hard, keep practicing hard. Cheers and God bless.